Okay, we continue our lesson. Industrial IoT. Okay, so we continue down last question I need to do here. Data solution, what kind of data would we have to class? So change one again. Okay. Okay. So study production and stuff. Priority data solution data handphone priority product and then label the password that is incorrect and using stamp uh, hammer stamp stamp control. Then we need information. So one word shift transfer label control battery load. Way. Product way. Okay. Uh, production speech sensor, we can have weight sensor, and then we can have camera. We can put the NFC, RFID. Yes, so we can detect the ID of the product. We can have something like counter, box counter. 1, 2, 3 sensor. Okay. Question. What big concern? New technology. And you will master the problem. Insulin. Do you have one stuff? I think the question about the budget. Question. Budget. Yes, what budget? And then okay. Yes, yes, and also budget. Okay, the quality of this employee. So no less. Quality of his employee. Something like this. Okay. J. Correct. Motor and tone low sensor that can detect vibration and noise, temperature, smoke, and glow. What maintenance? This one. 6 day. Okay. You can try this one again to see in the contest. Person should buy my smartphone, yeah, smart doorbell, smart camera, open noise, smartwatch. Let's send your heart rate and intelligent automobile that connect to cloud 10 years ago usually not have probably layer smartphone, yes. How many workers do we at any time to you? Whether IoT sensor technology one point to detect when I miss and disparity use cable satellite. Okay. Violation left. So use of Iceland the situation for when the nature when read or depend how nature and weather. You guys should be share with volleyball that comes up. Okay. Okay. Then we modify this one. So I can get my problem. Let's copy the answer. Okay, so we have the answer if something goes wrong. Okay, that's maintenance. Okay, okay, and then we can. This one have only 100 and they ask 100 or more. Emission. This one. Retest. Daily life. Okay. Pam 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 pam. Pum 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 pum. Pum 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 pum. Pum 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 pum. Pum 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 pum. Pum 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 pum. เอาคนท้อ with the Lloyd eight and let them know that checking that the IIoT checking is for the help for them to process them. Okay. เตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียน what yes that's it เตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเตียนเ Okay. Way number 3, cloud computing.
Another exciting trend that I actually mentioned in the introduction in this series is the cloud computing technology. In fact, cloud computing technology is transforming manufacturing process in multiple ways. In the context of IIoT applications of Industrial Internet of Things, I believe that cloud computing technology significantly changes both the scale and scope of IIoT applications in manufacturing. Let's understand how. What is cloud computing? Well, as you see on the left side of this chart, traditionally we understood computing is something that we have computers installed in our home or an office. In industrial business, we have computers installed in the premise, and those computers, yes, to some extent, all connected to the network, for communication or sending information, things like that. But the primary computer is mainframes or mini computers or personal computers. They're all in the premises of that business, right? That's how we understood, and they're on-site servers. All the information kept within those computers. That is traditional wave industrial computing. Well, a couple of decades back, the trend of cloud computing emerged, and fast as the high-speed interconnectivity and network evolved, we now have what is the capability called the cloud computing, where we store all the computing resources, right? The data and the logic computing power is distributed. They're kept in remote servers in the network, and often called as a cloud. Cloud is a network of high-speed computers. You actually kind of host your data and logic in these computers, and they're often managed by third parties, like Amazon and Microsoft and IBM, and they're also major cloud providers, including Google. And what does this actually, what is the capability that it provides? By centralizing the location of your both computing power and the data sources, and that being situated in a high-speed network, ubiquitously accessible from everywhere. Now, this now provides an opportunity that you can access beyond your proximity. In other words, the computer doesn't have to be in your building, or in your home. You can actually access information from anywhere that is present, as we all do when you log into Google and you search for something. You go to a website. There's nothing stored in your computer, but it's all actually in the cloud. This is a fundamental transformation because in various ways, and especially in the context of business benefits. First, there's a shift from ownership to access. Traditional computing, we believe that you need to own the computer. You need to have resources to kind of buy computers for you to have access to those computing capabilities. In other words, if you want to have access to a mainframe as a company, you have to own the mainframe, right? But that's not the case now. The shift is now ownership to access. I could be a small company that doesn't have the resources to buy a mainframe or a powerful computer, but I can access the computing power of a mainframe computer in the cloud, right? And then I can also, when I access that, they actually charge me only for the part that I access and I use. In other words, instead of buying and owning these assets as computers, now you have access on usage-based pricing. That's a big change, because what that does is actually it democratizes the access to computing, because the access to this computing power that was not available for small and medium companies, now everybody can access. That's one big change. The second piece is the elasticity, right? When you put the cloud, then you're hosting these big computers, and you can actually keep scaling the power there because it's all in a central location and it's being accessed for multiple users. So in other words, the term is called elastic scaling, because you can scale as you need. Today, this week I'm going to be doing some project. I need some high-speed computing. I can actually access that, and next week I'm not going to be doing any project like that. I can actually do with some small computing power. I could actually switch to that. So that's the elastic scaling capability that creates another huge opportunity. Now, how does it all connect to the IIoT applications, right? Now, if you think about when we define industrial Internet of Things, we said we go beyond computers to connect all these different kinds of devices, or they're called things, right? They could be, your tablet PCs, your phones, your industrial machines that are used in manufacturing, your simple sensors, right? Major kind of sensing, thermostat, whatever it is. All these are connected to the internet now, and they're stored in a common place. Now, instead of storing them in a traditional way in a computer, if you actually start storing them in a cloud, what happens? Well, then it gives the capability, just we talked about as in the case of thermostat example, all these manufacturing information from different machines, all these things could be stored in the central location of the cloud. Now, when you store it in the central location of the cloud, then that becomes accessible to anywhere in the world, right? So if you're a large manufacturing company with different multiple manufacturing plants, then you can actually access the data, real-time data coming from these sensors and these devices connected to the industrial Internet of Things applications, right? They can be accessible from anywhere. The decision maker, if she's either locally present or she's traveling internationally, she can still get access to all this information because it is now situated in the cloud, and you can actually access through cloud, right? Similarly, since it is elastically scalable, you can actually do this application in one plant. You can actually expand this into multiple plants as the kind of the size of this data expands, or the kind of logic actually expands. So you can actually manage these applications directly from cloud. So we'll talk later that you see that most of these IoT applications, industrial Internet of Things applications, are actually now more and more rendered on platforms that are sitting in cloud, especially because of these power that comes with the cloud computing. The another concept that you will actually come across more recently, in the last few years, is called edge computing. We call it, there's something called cloud computing and there's edge computing. Well, edge computing is nothing else but this external layer on top of the core cloud. Core cloud is the high-speed computers are connected. On top of this is this external layer. Now we connect all these different kinds of devices and things, as we call in Internet of Things. So they all have intelligence now. What is happening is that with the kind of miniaturization of processing power, and then and Moore's law, we have more and more intelligence in some of these devices, and they are actually connected to the periphery of the cloud, and that's why they're called edge devices, right? And this edge computing concept is more popular now because now as the companies think about designing business applications on industrial Internet of Things, they have to make a decision in terms of what kind of intelligence would they actually kind of keep on the edge of this cloud, and what will go in the core of this cloud. So there's an interesting trade-off in terms of what should be the intelligence at the edge, and then what should be in the cloud, as we design the application for it to be more scalable and usable across different locations. In summary, we talked about what is cloud computing. We understood how it's different from traditional computing, the way we understood computing 2 decades back, and what has changed, and what does it really mean to push all these computing power and data into the cloud. We also talked about the business benefits, right? How this cloud computing concept has fundamentally changed the economics of access to computing power, and how it has democratized access to computing power. Then we connected that with why the concept of cloud computing is important from the context of IIoT applications for large manufacturing companies, why they need that elastic scaling capability for them to scale and manage the scope of their IIoT applications. And finally, we touched upon the concept of edge computing and the importance of balancing the intelligence between what should be in the edge of these applications and then what should be in the core within the cloud for these applications.
Okay. Data.
Today, we have 2 industry experts who've got several years of experience working on IIoT technology across various customers in North America, Europe, and across the globe. We have Mr. Anil Pillai, who is the lead solutions and consulting head for Industry 4.0 at Tata Consultancy Services. We have Sachin Bhavsar, who works with Anil and is the senior consultant for Industry 4.0 at Tata Consultancy Services. So Anil and Sachin, welcome to the course.
Thank you, Professor. Thank you. It's a pleasure.
Yeah. Anil, maybe I'll start with you. You have, we all know about, TCS has been in this business for many, many decades now, and you've pioneered the digital transformation of manufacturing right from even before Industry 4.0. But with Industry 4.0, you have several engagements across across the globe. So, for our learners, can you pick a couple of examples, based on your engagement with clients as a system integrator, in working on IoT projects across the manufacturing industries? So, would you share a couple of IoT application projects that you've done?
Yeah, sure. Thanks, Professor. So, yes, I mean, we do have multiple examples of engagement spanning from developing, very foundational capabilities using IoT platform, as well as, advanced capabilities which are more model-driven, data-driven. So we have a spectrum of such use cases and capabilities delivered to customers. I'll pick some of them, which are, quite diverse in the sense we are talking about multiple capabilities delivered through the IoT construct. And one example I take is with our European customer, which is they are into cement manufacturing, and they have a big program running in wherein they are trying to move to a very data-driven operations. And when I say data-driven operations, they are talking about multiple data model-driven capabilities being delivered to business. Now, these are capabilities which are helping them in improving the reliability of the assets, the critical equipment that they are using at the shop floor. This includes process-related capabilities which are helping them predict quality issues. They are using this to avoid certain events in the process. So we are delivering for that customer various capabilities using the IoT construct. So let me take one example from an asset reliability standpoint, right? So the customer is multiple critical equipments at the process level, right? And any downtime associated with this critical asset directly impacts their production, right? So the first thing they are asking to implement is the ability to get a view on the health of their critical assets. So these critical assets are crushing mills, roller mills, right? So the first thing, from an asset standpoint, the capability that we are helping them realize is condition-based monitoring and predictive maintenance, right? So let me explain those terms, right? So we are talking about how we can use the historical data of the asset and model the asset so that we can use that model to predict upcoming deterioration, right? So the way we have conceived the solution is we conceived a health index for that asset, right? And as data starts coming in from the real-time sensors at the shop floor, the model will help us get a view on the current health status of the mill, right? Now that is helping the operators, the production supervisors to get a view as to how stable the current operations are, right? Second thing we are building for them is the ability to forecast this index for the upcoming days, right? So basically, we are using data analytics, data-driven model to forecast this index for the next coming few weeks, right? So that they can see how stable the mill is right now in the current operations, as well as they get a view around how this would be in the coming days with the historical data that we have used to model the asset, and that model being fed with the real-time data coming in from the sensors, we are able to also forecast this index for the upcoming weeks. Now this is very successfully been deployed in one of their plants, and now as we speak, we are taking it to multiple other sites for the customer, right? So that's one example from an asset standpoint. Now from a process standpoint, the same philosophy that we are using historical data to kind of completely simulate the behavior of the process, right? So in this example, there is a preheater, which is again a critical aspect of cement manufacturing. So what we are doing is again historical data of the preheater operations has been analyzed, and with that historical data, we have developed a model which again will alert an operator if the process parameters deviates, and if it sustains for a time, then the model will predict a blockage, right? And any blockage that impacts the production. So it's like they may have to stop the operation because of the blockage, right? Now the system is predicting that blockage much in advance, so that the operator can take the corrective action to prevent it or avoid that blockage, right? So that's another example. Third example is using image analytics. We are also helping them with correctly monitoring the quality of the cement that is produced, right? So these are some of the examples of how we have applied these technologies, and given the scale of operations they have globally, with the successful deployment at a pilot site, now we are taking it to other sites. We are taking it to other assets. So we started with one critical assets. Now we are expanding it to other assets, right? The other and other kiln and other, right? Even from the process standpoint, we are taking it to other process challenges that we have. So that's one interesting case wherein we are engaged with this customer.
That's very comprehensive. So you kind of you covered asset health monitoring, right, and kind of almost like a preventive maintenance for the assets, right, and then any process deviation. But the third one you mentioned is also quality applications, where you actually potentially are using IoT to test the quality of the end product as well, right?
Yes.
Right.
Yes.
Ecosystem.
We know that the focus of this course on the business applications of industrial Internet of Things technology. But in order to further understand the business context and how it's applied, I think it is important for us to have some understanding about the technology and the technical concepts behind how these applications are created. You need to build awareness about the building blocks that actually lead to these capabilities, and more importantly, the players, the different companies that come together and play different roles in developing and delivering these applications. So let's first start with the basic requirements. Like, you should never think about any IoT or IIoT applications unless you have your infrastructure right in terms of your hardware, your communication technology. Because just remember that all these applications that we talked about, some examples we use, they all rely on a good communication network that is high speed, there's got good latency, and so if you have problems with that, I think then it's going to be these applications are going to fall apart. So it's important to have the right hardware and the good communication network, and more important than that is the cybersecurity. Right, we'll come and talk about cybersecurity is a big risk. You have to protect these applications, because on one hand you get the advantages that you get real-time data access and you're able to make fast decisions, but at the same time now the data is in the network, so you have to make sure that you have all the cybersecurity steps taken for you to kind of launch any of these applications. Then on top of that, what I call is there are IoT platforms that are available commercially. Like we have MindSphere from Siemens is one of them, which allows for the gathering and organizing of the data and the logic and the different pieces that actually pull together these applications. And there are multiple platforms that are available in the market, and it is important to understand what the variety of platforms are and what their pros and cons. On top of that, then you have these platforms actually also connect with the enterprise software, such as ERP or your PLM software, the product lifecycle management software that actually runs the manufacturing process. These platforms connect with those software products. And also in a manufacturing context, you may have multiple devices, you have machines, and then a lot of these machines themselves are intelligent. And we talked about programmable logic controllers in machines, because the machines have ability to be programmed, and they have logic in them. So those machines will have operating systems, right, or software that also controls those machines. So we call it as device operating system. Any device, whether it is just like our phones has got an operating system or not. We call this as Apple's phone operating system, or Android. These are operating systems. These are software that control the device. So just like in our phone, we have other devices that are used in the manufacturing context. They will have their own operating system. So these platforms, they actually connect with those operating system software. And so with all these capabilities, on top of that, what you build is the IIoT applications. In other words, any of these, say, preventive maintenance application that I was referring to earlier. So that particular application, they will connect with the device operating system of that particular machine. It will connect with the IIoT platform that you've chosen, so that how you're organizing the data and the logic, where you're storing it, and which cloud architecture, and things like that. And then it'll also, that particular software or application, IIoT application, sometimes may also connect with your enterprise software. So that set of connectivity that I talked about with this platform and the device operating system, that is what leads to the IIoT application. Of course, this entire application is sitting on high-speed communication network that you've kind of architected, and we're also all protected with the cybersecurity software layer that actually protects this vital information. And of course, more recently, what has happened is the entire IIoT platform, they've been kind of moved to the hyperscaling cloud architecture, because now with companies like Amazon AWS or Microsoft Azure or Google Cloud, they all offer what is called as hyperscaling, because their ability to scale is enormous. In terms of they can take us a manufacturing company from one single plant, they can connect the same application, give access to that application across multiple plants globally, so they can scale it the way they want in terms of both global access and also in terms of computing power. So that's why you'll find that most of these IIoT applications are now kind of rendered from these hyperscaling cloud platforms, and these IIoT platforms are in fact hosted in those the cloud architectures. It is also important for us to understand who are some of the major companies that actually are playing roles in various layers, as I've kind of showed in the diagram here. I mean, you certainly have appliance and hardware manufacturers. Siemens is actually both a hardware manufacturer and also a software manufacturer, because they provide both. In fact, they're very well known for their platform Mindfield that actually connects all different IoT applications, and also more complex applications using the IoT capabilities. You have companies like AdLake that actually connects to your balancing the cloud and edge intelligence distribution that we talked about earlier. We have specialist companies like Fastly, which actually kind of provide this edge computing platform. We have NVIDIA, which is actually a chip company, which is a very, very dedicated GPUs, graphic processing unit, or high powered very fast chips that are dedicated for particular applications, so that you can put that in a specific edge application. So there are chip companies that are playing here. There are system integrators, right? Like Accenture, IBM, or Tata Consultancy Services, Deloitte. All these are what we call them as system integrators, in the sense they work with multiple platforms and they actually bring together all these different parties, and they take ownership of working with their clients to kind of deliver this IoT application, in the context of that particular manufacturing company. And some of these system integrators, more recently, they also have their own platform, like TCS or Tata Consultancy Services. They have their platform. IBM has its own platform. So that when you're developing applications, sometimes they also can bring their platform. And of course, the hyperscalable platform that we talked about earlier, Amazon's AWS and IBM's platform for IoT, is also kind of from cloud and Azure. These are some of the examples of how different companies come together. The reason I'm actually sharing this is when you are learning about these industrial Internet of Things applications, it is important for you to know what goes with behind the screen, and then how these all come together. Because for rolling out and thinking about new applications, it is important to understand who are the players, who are the partners, and then how do you make use of these partners to kind of build a viable and scalable solution for you.
Okay.
So Anil and Sachin, I think TCS is an interesting position. It's an interesting position in this IIoT application evolution in the industry, right? I mean, TCS has evolved more as a systems integrator, doing a lot of custom project, around these the manufacturing, first enterprise systems, then the operational technology, and then bringing these things together as IoT application. But more recently, I also learned that you also have your own platform, right, in terms of building an IoT or digital twin kind of platform where you connect these pieces together. Tell us about the journey, and also give us a picture of how you see this ecosystem evolving.
Sure. Yeah. So yes, I mean, IoT as a space is definitely, we have so many players, right? And when we talk about capabilities enabled to an IoT platform, it is not just limited to the IoT platform itself. For example, if I were to talk about a capability like predictive maintenance or optimization, it calls for components that will come right from the foundational layer, which is identifying the right sensors that can give us the data, identifying the platform on which this application will be built, identifying the right components that will be used for the development of analytics algorithm, right? So whenever we talk about any capability being realized in this particular space, there are multiple players that come into play. And TCS, I would say, depending on the various engagements that we have and specific customer needs, we are engaged with customer where we are purely a system integrator, bringing in the capabilities that are required to build this kind of application on a customer chosen platform, right? So that would be one of the examples of our play. Second is where the customer is also looking at recommendations and support in identifying the other components, right? So it could be technology evaluation with respect to sensors. So we help customers identify the right sensors, identify the vendors who can provide those right sensors, help them evaluate the different technologies, the different components that come into utilizing this kind of capability. So the other aspect of our involvement is not just limiting to developing those capabilities on a chosen platform, but helping customer identify the right platform, identify the right vendors who can supply those different components, to build those capabilities. Third, I would say, yes, I mean, we do have our own platforms, wherein depending on the specific customer requirements, we do position our own platform as well. And these are platforms which are specific to meeting their data analytics needs. These are platform requiring IoT construct, capability construct kind of platform solutions that we have from TCS. So and I would say we are engaged wherein we have examples where we are purely a system integrator player. We have examples where we have our own platform being used by the customer to realize this capability. And we have a broader ecosystem today wherein we bring in the right vendors from the ecosystem, whether they are supplying us with the right sensors, with the right cameras, and as required. I mean, depending on the specific use case needs, we play a bigger role in kind of bringing in the other players to help customer realize the capabilities.
Okay.